Good evening, everyone. Hope we are all well. Okay, so in this session, we're going to be looking at Mathematics Paper 2. Our question of interest is cubic functions. Initially, we looked at this lesson during our live sessions, but some of you missed the class. So this session is specifically meant to help those of you who missed the class to catch up, because in the next session, we will be concluding this topic, which is tomorrow. So like I mentioned to the other guys, this question is only expected in two versions. The first version is where they give you the graph. Okay, they already draw the graph for you, something like what you're seeing on the board. So I'm using a differently drawn graph, but using the same formula and coordinates, because the original one in the exam paper is blurry, and so you can't see properly the coordinates and all that. So they'll give you something like this, okay, or something like this, and then they'll ask you a couple of questions about it. Yeah, or the other version, they will just give you a box of values, okay, a table of values, of which within that table of values they will hide one of the values. Then the first question will be to find that hidden value. Once you find the hidden value, and then they'll give you a scale and then ask you to draw the graph. Once you draw the graph, then they'll ask you follow-up questions like they are asking right now. So those are the two versions you expect in your exam. Either they give you this one already drawn graph, then they just ask you questions, or they give you a table of values, hide one of the values, ask you to find the value, ask you to draw the graph, and then again they ask you these questions. Okay, so in this session we're going to look at what we looked at in the previous session, the one you missed, where we have the graph given to us and then we simply answer the questions that are given. All right, so there are some questions that we already looked at the time we're looking at calculus, because there's going to be a bit of calculus here. Calculus and coordinate geometry, it features in this topic. So I'm not going to touch those topics because we've done them several times, and at this point I believe you know how to solve these questions because we've done them several times, unless you abandoned what we looked at and you just started going with the flow. Okay, if not, resources are there, you can still go back to those lessons and relearn them. Yeah, so in this session I'm just going to touch on what we have not covered with you. Everything that we've covered I'm going to be skipping. Yeah, so that is that. So it simply means I'm going to skip this question because we've already done it. I think I even gave it to you as an assignment, if not solved as an example. So I'll just go direct to the next one, which is this one. So they've given us the equation of the graph, which is this one here. So it simply means this graph, the equation is y is equal to x cubed. I know you may not be able to see clearly because the paper is a bit blurry, minus 3. This is the equation of this graph. Okay, and now the first question they are saying, use the graph to find the solution of the equations. You have this equation right here as the first question. So to solve this question, what you need to do is write down, of course you indicate the question number. You will be solving all these questions on your graph paper, by the way. Since this is the new way, like they'll give you a different exam paper as opposed to this one you're solving. So they'll give you a plain paper. Actually, there'll be a graph paper with a graph on it, and then they should provide some space for you to write your answers from. So you're basically covered. So first thing first, you write the equation, the original equation of the graph, which is what we have up there. So I'm going to say y is equal to x cubed minus x squared minus 5x minus 3. And then next thing, you write this equation you're trying to solve, this one, which you'll notice in this case is just the same as what we have up there. Okay, minus 5x minus 3, except it is equated to 0. So your goal when solving this question is make sure the values on the left of the equation you're trying to solve match exactly the values of the original graph. When these values match, it simply means they are going to cancel each other out, like that. And then your y will now be equal to what is remaining on the right. So in this case, our y is just 0. Okay, so now this is an inequality which we need to draw. So to draw that inequality, let's grab a ruler from here, we place it there, and then we draw the inequality. So let me just align it. So where y is equal to 0 is just basically on the x-axis right here. Okay, so I'll come here and draw our inequality. Like that. And then we can name it, this is y is equal to 0. Then you're going to check for the x coordinates where this particular graph is cutting or touching through, touching the graph. So you notice to say it is touching the graph at -1. It is also cutting through the graph at 3. So meaning your answers are just going to be x is equal to -1 here where it's cutting or touching the graph, and then the other one is going to be x is equal to 3 here where it's cutting through the graph. Those are your final answers, and you are done. Okay, we proceed to the next one. So the next one says this is the equation, right? So again, first things first, you write the original equation for the graph, which is y is equal to x cubed minus x squared minus 5x minus 3. And then now you write this equation you are trying to solve, which is x cubed minus x squared minus 5x is equal to x minus 3. So now you notice to say here the 3 is missing on the left side here, but it's this side, so we need to move it from this side to the left side of the equal sign, which is now going to be x cubed minus x squared minus 5x. When this 3, which is negative, crosses, becomes positive here. Okay, meaning this side will just remain with an x. Okay, once you do that, it now means that and that will cancel, that one and that one will cancel, that one and that one will cancel, that one and that one will cancel. So meaning your y will just be equal to what is remaining here, which is an x. So y is equal to x is your inequality. Now to draw this inequality, you need what is known as a table of values. You need to draw a table of values, or you can simply, okay, let me use a table of values because we're going to use a table of values even the time we'll be looking at linear programming. So I will use this method so that you get used to it. By the time we get into linear programming, you should be good to go. So at most you just need about 3 coordinates. Okay, yeah, so here we're going to put x, here we're going to put y. Okay, your formula is this one. That's what you're going to be using to come up with a table of values. So now for this type of inequality, let me also introduce, because we'll find these inequalities in linear programming. For this type of an inequality where you say x is equal to y or y is equal to x, this is a type of inequality that has identical coordinates 0, 0, 1, 1, 2, 2, 3, 3, just like that. The x coordinate and the y coordinate are always the same. Alright, but since this is when you're getting exposed to it, we're going to find these coordinates manually. So now you go to your graph and then you check what is the scale, what is the range for my x axis. You notice that it is starting from -x, -2 going up to +3, meaning you can use any of those coordinates. You can either test for -2, -1, 0, 1, 2 or 3. What do you mean by that? Simply go to your equation. Let's say we're testing what if x is, let's use the last coordinate here on the left. What if x is -2? I'll get my -2, I put it there. We're now trying to see if x is -2, what is going to be the coordinate for y. So now here we get this formula, right? Write it down here. Where there's x, we put a -2 and then solve to find y. But in this case, you notice to say y automatically becomes -2 as well, right? So meaning y is -2. Okay, let us test for 0. What if x is 0? Remember, I'm using coordinates that are lying on the x-axis up here. Okay, right there. Those are the coordinates I'm using. Just pick any of those. What if x is 0. So meaning where there is x, where there's supposed to be x here, I'll put a 0. You will notice now that y automatically becomes what? A 0 as well. So meaning y is 0. What if x is positive 2? Okay, let me test using this coordinate here. What if x is positive 2? Okay, this is my formula. So meaning where there's x, I'm supposed to put what? A positive 2. You indicate there that. Meaning y also becomes what? Positive 2. What if x is 3? What would be y? This is my formula. Y is equal to x. I'm testing for x. So meaning where there is x here, I need to put the positive 3 I've put there. Y becomes 3 as well. So these are the coordinates we're going to use to draw our inequality, which are negative 2, negative 2, 0, 0, 2, 2, 3, 3. As you've seen, just like I mentioned, the coordinates are always the same for this type of inequality. So now let's go ahead and plot these coordinates. We can erase that inequality. So we have negative 2, 0, negative 2, negative 2. So this is negative 2 for x. Where is the negative 2 for y? So now we need to determine what does this box represent. This box. Okay, you can see the graph has several boxes. So what we are trying to achieve is what is the coordinate from here to here. If this is 0 right there, if this is 0 here, what is the coordinate here? That's what we're trying to determine. Okay, because the scales are different. Okay, this one, by the way, this whole box represents 2 centimeters. So according to this scale, this is 2 centimeters to represent 1 unit, meaning from here to here it is 2 centimeters. From there to there it's 2 centimeters. From there to there it's 2 centimeters. That's when it comes to interpreting the scale. However, on the y-axis, from here to here it is also 2 centimeters, but in this case they are using 5 centimeters, 2 centimeters to represent 5 units. Okay, that is why from here to there it is 5. Okay, from there to there it is 10, because it is 2 centimeters to represent 5 units. So if from here to there it is 5, how about from there to there? Okay, so we're going to start testing. You can start with the smallest number, which in this case is going to be 1. This is 0. If you say 1, 2, 3, 4, 5, you have actually confirmed to say one box is representing 1 centimeter, right? Because from here we say 5, 6, 7, 8, 9, 10. That's how you confirm to say, oh, so one box is representing this much. So now we're looking for negative 2. So meaning this is 0, 1, 2. So this is the line for negative 2. And then this is the line for negative 2 on the x-axis. Where these two are meeting, that is where we put our coordinate. Right there. Okay, let me just place it in the right place. I'll make a bigger one just for you to be able to see. Okay, a bigger dot. But in the exam, don't make them that big. Make them reasonably big. The next coordinate we have is this one here, which is 0, 0. So I'll go where there is 0. Right there where those two lines are meeting, that is 0, 0. Next one we have is 2, 2. So this is the line for x passing at 2. How about 2 for the y-axis? So we've already determined that one box is representing 1 unit. So you can simply say this is 0, 1, 2. Okay, or you can do it from here. This is 0 right there, 1, 2, and then you draw a line. Don't really draw a line, just take note of that line. Okay, where these two lines are meeting, they're meeting right here. That is where your coordinate is going to be. That is 2, 2. Okay, but if you like, you can actually just use on the x-axis. You know this is 0, right? Then you say 1, 2. Then you put your coordinate there. So that's the next coordinate. The next one is 3, 3. Okay, so this is 3. We know this is 2, right? So we just go and we just go just a line upwards to the next line, giving us our 3, 3. Okay, this is 3, 4, 5. Okay, 3, 4, 5. Right, therefore our 3, 3 is there. Now if what you did is correct, these dots that you have right here, they should all be in a straight line. Once one of them is off, just know that the time you are coming up with a table of values, you did something wrong. Okay, and one of the coordinates, that's how you find maybe the coordinates are staggered. They are not going to be in a straight line. So let's check, did we do the right thing when coming up with these coordinates? Let's try to align our ruler in such a way that it touches all these coordinates. They should all be in a straight line. You now notice to say they actually are in a straight line. So now go ahead and draw your line. You draw that particular inequality. So make sure it is long enough to check whether it's cutting through the graph or what. Don't just start it from here and end it from there. That would be wrong. No wonder it is long enough, starting all the way from here up to this side, so that we take note of all the points where this line is cutting or touching the graph. So now at this point, you notice to say it is cutting through the graph at that point, and that point. Now our point of interest are x coordinates. So what you do, if the point where the line is cutting or the inequality is cutting through the graph is below the x-axis, the x-axis is up here. Just the x-axis is right here where the coordinates are. This is the x-axis, this one, that's the x-axis, and this is the y-axis up there. This one going up like that. This one is our x-axis. So what you are looking for, if the point is below the x-axis, okay, this is the x-axis right here. The point here, not there, the point right there is below the x-axis. So you need to go up to the x-axis and check for the coordinate. So meaning we're going to go up and we check what is the coordinate for the x-axis right there. So again, we need to determine how many boxes, what does this box represent on the x-axis, because even the scale is different here. So we're going to test. Okay, if we say we can't obviously use 1 because this is 1 and this will become 2, but we already have our 2 here. So meaning we can't use that. We need to now go down to decimals. How about we start again with the smallest? How about 1.1? So this is 1, 1.1, 1.2, 1.3, 1.4, 1.5. But we have 2 here, meaning the decimal we're using is smaller. Let's increment it by 1, 1.2. Okay, so we're going to say 1, 1.2, 1.4, 1.6, 1.8, 2. Okay, this is 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. So we have confirmed to say on the x-axis, one box is representing 0.2. So meaning, what is the coordinate at this point here? We're going to start counting from here. So we are looking for the coordinate at that point where this line is cutting the graph. So we start from here. This is 1, 1.2, 1.4, 1.6. So I'm now going to indicate to say this is b, x is equal to negative 1.6. Okay, this is 1.1, 1.2, 1.4, 1.6. Okay, we've taken note of that coordinate. We now go to the next one, which is right here where it's cutting through the graph. So we go up to the x-axis again and check what is the coordinate here. So we've already determined that it's 0.2 per box, for a smaller box. So this is 0, 0.2, 0.4, 0.5 for that one right there. Okay, remember we're going towards the negatives this side. So it's going to be x is equal to negative 0.6. That's your coordinate there. We now go to the next one, which is where right there. So this one is above the x-axis, so we need to drop down to the x-axis. Then we check what is the coordinate right there. So this is 3, so meaning this will be 3.2. So we're going to say x is equal to 3.2. These are your answers. Okay, those are your final answers, and you are done. You go to the next one. Find the gradient of the curve. So whenever you're asked to find the gradient of the curve, just know that I am differentiating the original function for the curve. So the original function is the one we have been using. Okay, it was also given to us in the question. You can see it is right here. Okay, so what you simply do is you write down that original function. Y is equal to x cubed minus x squared minus 5x minus 3. You differentiate this one. Okay, dy over dx will be equal to, So remember, to differentiate we multiply, so it's going to be 3 times 1x the power 3 minus 1. You always take away 1 from a 3 when you are differentiating. Again, there the power is positive 2 times negative 1 x the power 2 minus 1. We've already done this, so that's why I'm closing. What's the power of x there? It's positive 1. So positive 1 times the coefficient of x, which is negative 5. You can put that in brackets. The power x, the power 1 minus 1. And then to differentiate a constant, it just becomes a 0. So our final answer will therefore be equal to 3 times 1 is 3x squared. 3 take away 1 is the 2 you are seeing there. Okay, positive times negative there is negative. 2 times 1, that's a 2x the power 1, because 2 minus 1 is 1. Okay, positive times negative there is negative. 1 times 5 is 5x. 1 minus 1 is going to be a 0 there. Okay, any value raised to the power of 0, so this will become negative 5. Okay, any value raised to the power of 0, remember we looked at this the time we were looking at indices, is a 1. Negative 5 times 1 is negative 5. So in this case, we can safely delete that guy. So this is our differentiated function. So now, remember the time we're looking at calculus, we said dy over dx is equal to the gradient function. Alright, so now for us to find the gradient of the curve, we get this same differentiated function. Wherever there is x, we plug in the x coordinate they've given us in the question. Gradient of the curve at the point negative 2, 5. So we're going to get this differentiated function, and then where there is x, we're going to put what? The negative 2, the x coordinate here. So we're going to say 3 negative 2 close bracket squared minus 2 open bracket negative 2 minus 5. Okay, meaning our gradient will be equal to, then I can go ahead and punch. So that is 3 open brackets negative 2 close bracket squared minus 2 times negative 2 close brackets minus 5. 3 times negative 2 squared minus 2 times 2 times negative 2 minus 5. That is giving me 11 as my gradient, and I'm done. Okay, just like that. Differentiate the original equation for the curve, then wherever there's x in your final answer, plug in the x coordinate you will be given in the question, then solve. That will be your gradient. As simple as that. We come to this one now, area bounded by the curve, where x, let me just clear the screen. Area bounded by the curve where x is equal to 1, y is equal to 0, and x is equal to 3. So the coordinates we have are x is equal to 1, y is equal to 0, and x is equal to 3. So for this particular question, all you have to do is get the original function of the curve again, which is x cubed minus x squared minus 5x minus 3. Okay, this is the original equation of the curve. Let me just confirm. Yeah, we said it's the same one as this one, x cubed x squared 5x minus 3. Once you get that one, integrate it. Okay, but in this case the x coordinates, the 1 and the 3, are going to be your upper and lower limits. Okay, so the bigger value becomes the upper limit, the smaller one the lower limit. Okay, that is for when y is equal to 0. Y is a boundary. When the boundary is equal to 0, this is what you do. Simply get x to the power 3 minus x squared minus 5x minus a 3, and then here you have the upper limit and lower limit. The x coordinate here is 3, there it is what? 1. Then integrate. Okay, so to integrate, remember we add a 1 to the power of x, so it's going to be 3 plus 1 over 3 plus 1 minus x 2 plus 1 over 2 plus 1 minus 5x 1 plus 1 over 1 plus 1. You know how to do these things. Okay, whenever differentiating integrating a constant, you need to add an x, raise it to the power of 0, add a 1 over 0 plus 1. Then there you have your upper limit and your lower limit. Okay, here when we solve, we're going to get x to the power 4 over 4 minus, here we're going to get x to the power 3 over 3 minus 5x squared over a 2 minus 3x. Okay, the upper limit is 3, lower limit is 1, and you are done. Okay, you are done integrating. There's nothing you can simplify here. So at this point, all you have to do now, let me try to scroll down. So you're going to open a bracket here. In the left bracket, where there's x, this is a, let me just move this guy upwards. This is our integrated function. That's what we're going to use. Okay, wherever there's x, you put a 3. So we're going to say 3 to the power 4 over 4 minus 3 to the power 3 over 3 minus 5. Okay, in brackets we have a 3 there, squared over a 2 minus 3 in brackets 3. You close the bracket and then say minus. So in the left bracket, wherever there's x in this function right there, we have plugged in a 3. In the right bracket, wherever there is x, we are plugging in the lower limit. So then it's going to be 1 to the power 4 over 4 minus 1 to the power 3 over 3 minus 5 in brackets 1 to the power 2 over 2 minus 3 in brackets 1. You close, and then you punch these values on your calculator. Okay, so you already know how to do this. So for me, I'll just punch everything at once, and then we check the final answer. So my upper limit is 3, lower limit is 1, and then I can, in the brackets, I'll say x to the power 4 okay, x to the power 4. So my calculator is actually able to punch the original equation, x to the power 4 over 4 minus x to the power 3, x to the power 3 over 3 minus 5 times 3 squared, not really 5, I'm now mixing up things. Okay, I'm just supposed to punch the coordinates, the values, the way they're supposed to appear in the original one. Okay, just give me a moment. So 3 1, okay, that is x to the power 4 over 4 minus x to the power 3 over 3 minus 5x squared over 2 minus 3x. I confirm that I've punched the correct values. So I have upper limit 3, lower limit 1, x to the power 4 over 4 minus x to the power 3 over 3 minus 5x squared over 2 minus 3x equals, okay, looks like I punched something wrong somewhere. I think I forgot to put the opening brackets. Yeah, so that is x to the power 4 over 4 minus x to the power 3 over 3 minus 5x squared over 2 minus 3x, close bracket. x to the power 4 over 4 minus x to the power 3 over 3 minus 5x squared over 2 minus 3x. Okay, so that is giving me negative 28.2333333. Should be 1 2 3 4 5 6 7. So now this is area. Area is always positive. Huh? Remember the question says find the area bounded by the curve. Area here bounded by the curve. So whenever you get a negative answer, convert it to a positive. So it's going to be 28.23 units. Remember area is always squared, like that. That would be your final answer. Okay, area is equal to that, and you are done. So whenever you're dealing with this question, simply integrate the original function. That is when your y is equal to 0. Integrate the original function, and then you apply the upper and lower limits. Your x coordinates become your upper and lower limit, and then solve. The final answer should always be a positive, but you need to convert it to a decimal in case the calculator gives you a fraction. So we are done with question 1. We go to question 2. So question 2, we looked at this question the time we were looking at calculus in last time, so I will not solve it again. Remember, I did mention that those questions that we've already covered, those that I know you know how to solve, I will not touch them. I'll just touch those that you missed. So, but here are some pointers. For this one, what you're going to do, the first thing is you're going to differentiate this function you have there. Once you differentiate it, you are going to find the gradient like the way we found the gradient for the curve. Okay, once you differentiate, okay, of which I can quickly do for you right now. I'll do shortcuts, so in case you don't understand, just follow the right method. I know this will change to 0, this here will change to 3, and then this here will change to 3x. This is the differentiated function, dy over dx. Okay, I've differentiated the function. Then here, where there is x, I'll plug in the x coordinate. The coordinates I have are 1, 1. So meaning it will be 3 minus 3 times 1 there. I plug in the x coordinate. The x coordinate is a 1. You can see it right there. Okay, I'm trying to find the gradient. When I multiply those values, when I simplify, I'm just going to get that's okay, let me see if I did the right thing. To differentiate, that will be, oh no, this is going to change to 6x, because it is 2 times 3 giving me a 6 there, minus 1 there giving me a 1 there. So meaning here I'm going to have a 6. So that will be that there, my gradient will be negative 3. Once I find the gradient, I can now use the formula for finding the equation of a straight line. y1 is equal to mx minus x1 there. So meaning I'll say these are my coordinates up there, the x coordinate and y coordinate right there. So I'll plug in y1 here, which is a 1, is equal to gradient we found negative 3. X minus x1 is that one there. So y will be equal to negative 3x plus 3, and then this will come to the right, becomes positive 1. Final answer you find is negative 3x plus 4 as the equation for the tangent. So here are some takeaways for you. To find the equation of the tangent when you are given the equation of the curve, first thing, differentiate. This is what we did here. Once you differentiate, where there is x, you now need to find the gradient. Where there is x in your differentiated function, this one right there, you plug in the x coordinates. That is what we did there. Okay, to find the gradient of the curve, which is also the gradient of the tangent. Once you found the gradient of the tangent, this one, you can use it together with the coordinates you are given in the question to find the equation of the tangent. So this is our equation for finding the equation of a straight line. Where there is y, you put the y coordinate. Where there is y1, you put the y coordinate. Where there is x1, you put the x coordinate. That is the one you are seeing there and the one you are seeing there. Where there is m, you plug in the gradient you found, which was negative 3. This is the negative 3 you are seeing there, and you solve. That is your final answer there. Okay, we proceed to the next one, which is now this graph. So this graph, the equation of the graph is y is equal to 27 x minus 3 minus x cubed. Actually, let me write it inwards so that I can reserve space for the solutions. So y is equal to 27x minus x cubed. That's the equation for the graph. We got the questions. First question is asking us to find, use the graph to solve the equations. Same format like the previous one. This is the one we're trying to solve. So first thing we said, you write the original equation for the graph, which is this one here. So we're going to say y is equal to 27x minus x cubed. Then secondly, you write this one which you're trying to solve, which is 27x minus x cubed. You notice to say this one is equated to 0 now. Here we have the same values. Remember we said you make sure that on the left side of the equation you're trying to solve, you should have the same values as in the original equation for the curve. So meaning this and that will cancel. Y will then be equal to what is remaining on the right side of the equal sign here, which is 0. So meaning your inequality is just y is equal to 0. Y is equal to 0 is right on the x-axis. Remember we need to draw this inequality. Y is equal to 0. Okay, so we go ahead and draw that line. Then we check, make sure it is long enough. Again, I did mention this. We check why it's cutting through the graph. It's cutting through the graph at 3 points. You simply have to indicate what are your x coordinates at those 3 points. So here, oops, what is the coordinate at that point? So this one, this is negative 4. Let's say negative 4.2, 0.4, 0.6, 0.85. Okay, so meaning one box is representing 0.2. So this is negative 5, negative 5.2. So the first coordinate is negative 5.2. I did explain how to come up with, how to figure out what one box is meant to symbolize. Then here it is 0. X is equal to 0. And then the last coordinate, okay, right here. Okay, so if this is 5, this will be 5.2. So 5.2. These are your answers, and you are done. We go to the next one, which is this one here. Okay, now first thing first, again we do the same thing. Draw the equation of the original graph, which is y is equal to 27x minus x cubed. Then draw the one you're trying to find, which is this one right there. So this one says 27x minus x cubed is equal to 5x plus 10. Okay, let us move it a bit to the right. So now here you notice to say on the left, remember I'll go on the left side of this part, this equation, on the left part here, left side of the equal sign, they should be identical to the original equation, and they are, meaning those can cancel out. So this and that will cancel, that and that will cancel, meaning y is now going to be equal to what you have remaining on the right. So y is equal to 5x plus 10. That is your inequality. You need to draw this inequality. How are you going to draw it? You need to come up with a table of values. Okay, you need at least 3 coordinates. Okay, you have x there, you have y there. Where are we getting these coordinates? We check the x-axis. Okay, this is the x-axis. Okay, we can test any of these coordinates. We can even stick to these. Okay, but to be safe, also use some from the negative side. So let us go to the left. Let's start with negative 4. You can see there's negative 4 on the x-axis here. So I'll go to the right. Just go to the right. Come on. Okay, so we're testing for negative 4. Negative 4 is there on the x-axis. Negative 4. If x is negative 4, we're going to say y is equal to 5. Well, we're supposed to put x here, we'll put negative 4. We're trying to find the value for y. So meaning y will be equal to 5 times negative 4 is negative 20 plus 10. So meaning your y will be equal to what? Negative 10. So y is negative 10. Okay, let us test for a positive one now. Let's pick 2. On the x-axis there is a 2 there. Okay, if x is equal to 2, what is going to be the y coordinate? So I'm going to say y is equal to 5x plus 10. So y is equal to 5. While there's x, I'll put the 2 I'm testing. So I'll put a 2 there plus 10, meaning y will be equal to 5 plus 2 there is 10. 10 plus 10 gives us a 20, meaning y is equal to 20. We go to the next one. What other coordinate can we pick on the y-axis? We can pick a 5. There's a 5 here on the y-axis. So the formula is y is equal to 5x plus 10, right? So we're going to say y is equal to 5. While there's x there, we put the 5 we're testing. So meaning 5 there plus 10. So y will be equal to 5 times 5 is 25 plus 10. Y will be equal to 35. So our y coordinate is 35. These are our coordinates. Now let us go ahead and plot this inequality. So let me just capture the coordinates. What are the coordinates? We have negative 4, 10, negative 10. The other ones we have 2, 20. I'm getting them from the box, and 5, 35 actually. These are our coordinates. Let us now go to the left side and plot these coordinates. Okay, and remember we said if you do the right thing, these coordinates should be in the same line. Okay, in a straight line. Let us go ahead and plot. Let's clear up some space. So we have negative 4, 20. Negative 4 is this line here for the x. Y is 20. 20 for the y is negative 20, negative 10 actually. So this is, if this is 0 and this is 20, meaning each box is going to be what? Okay, so let's say 0, 2, 4, 6, not really, 0, 2, 4, 6. How many boxes do we have here? 1, 2, 3, 4. 1, 2, 3, 4. So there's a box missing here, I think, for this particular graph. So meaning our 10 should be roughly, so we have 1, 1. So our 10 should be roughly here. Okay, half of this bigger box. Okay, half of this bigger box. Half is somewhat here. So this graph is problematic. So our 10 is here. Okay, so where these lines are meeting, they are meeting right there. That is where your negative 4, 20 is going to be. Put a dot there. I'm just making them big enough for you to see. Next one we have 2, 20. This one we have plotted that one. 2, 20. 2 for the x is here, 20 is right there for the y. So where these two lines are meeting, positive 20 actually, positive 20. So it's up here. Okay, 2, 20. Where these two lines are meeting, they are meeting right here. So that's why our coordinate is going to be. Next one is 5, 35. 5, 35. So 5 is this line here. This is 5. So if this is 20, meaning 30 will be here, and this will be 35. Okay, so 35 is this line here. So where these two lines are meeting, right there. Okay, now let us check if we did the right thing. These 3 points should be in a straight line. Let us test. Are they in a straight line? Okay, let's try to turn the ruler a little to check. Okay, let's move it a bit to the left like that. Okay, so I can't smoothly move my ruler. I don't know why. Let me try to hold down a key. I can't smoothly move it so that these points are in an exact straight line. It's skipping one point, which is now making me miss another point. Okay, so it could be because of that missing box also for this graph. But initially what you're supposed to get is a straight line. You can see they are pretty much close, but because I'm using the laptop to do this, I may not get the exact same point, but initially they're supposed to be in a straight line. Okay, let's try to get the last two to be in the straight line, and then we'll go for that one. Okay, I keep missing them. Okay, let's go for the first two. Once these are aligned, we can draw our line. So this is going to be our line, and then we check where are these. So it's cutting the graph in 3 points. Is it at 3 points? Yeah, at 3 points. Okay, so now we need to gather the x coordinates. We need to collect, or identify rather, the x coordinates. So here it's cutting right there. We check what is the x coordinate there. So it's somewhat at the center right here. What is the coordinate there? So this is 4, so that is 4.2, 4.4, 4.8. Not really, I've messed up. Let me try again. This is -4, -4.2, -4.4, -4.6, -4.8. so since it's at the center, we can say it's -4.9. so I'm going to say x is equal to -4.9. that's the first x coordinate. The second x coordinate, where is it cutting? It's cutting right here, so I need to drop down to the x-axis since the point is above the x-axis. So this one is closest to, it's not really at the center, is it? Looks at as if it's at the center. So what is the coordinate right here? So this is 0, 0.2, 0.4. Let me use straight lines. We're trying to determine the coordinate at that point. So this is 0.2, 0.4, 5. So you can say x is equal to 0.5. That's a positive coordinate. The last one is going to be x is equal to, it's cutting right here, so we need to drop down to the x-axis and check. That one is not at the center, so we round it off to this one. Okay, so what's the coordinate there? 4, 4.2, 4.4. so x is equal to 4.4, and you are done. Those are your final answers for that inequality. We now go to the last question, which is asking us to calculate an estimate of the gradient. Remember I said whenever you are asked to find the gradient of the curve, all you have to do is differentiate the original function. So the original function is 27x minus x cubed. Let me confirm. Yeah, it's the one. So we need to differentiate this equation of the curve. Let me scroll down. Okay, so meaning to differentiate, we are going to say dy over dx is equal to, so the power there is 1 times 27x, 27x, the power 1 minus 1, okay, plus, the power is positive, so we're saying plus 3 times -1, x the power 3 minus 1. So our final answer will be equal to 1 times 27 is 27, okay, x the power 0 there, 1 minus 1 is 0, okay, positive times the negative right there is negative, 3 times 1 is 3, x the power 2, okay, 3 minus 1 is a 2 there. So our final answer is just going to be dy over dx is equal to 27, because this will change to a 1. Any value raised to the power of 0 is 1. 1 times 27 is 27 minus 3x squared. Once you differentiate, you get the x coordinate. That is how come you've noticed here they've just given us one coordinate, the x coordinate. We're now trying to find the gradient of the curve. So we get this differentiated function. Where there is x, we plug in the x coordinate given to us. The x coordinate we've been given is a 2. Okay, let me circle it properly, this one here. So I'm going to say 2 squared. When you punch that on your calculator, what do you get? 27 minus 3 times 2 squared. 27 minus 3 times 2 squared, that gives me 15. So the gradient of the curve is just 15, and you are done. Okay, we come to the last one, which is the area. We said whenever asked to find the area, it's integration. Okay, area bounded by the curve where x is equal to x-axis. X is equal to x-axis is the same as x is equal to 0, and then you have x is equal to 3. So these are your coordinates, your x coordinates. Remember I said you integrate, and these will be your upper and lower limits. Okay, so the important ones mostly for this question are the x coordinates. That's how come you've noticed there is no y coordinate here. So we're going to integrate the original function, which is 27 x minus x to the power 3, and then these guys will be your upper limit and lower limit. So to integrate this one, we're going to say 27 x1 plus 1, okay, over 1 plus 1, minus this one will be x 3 plus 1 over 3 plus 1. Upper limit is 3, lower limit is 0. Let us scroll down. Not what I intended to do. Okay, we scroll down like that. So we finished integrating. There we're going to get 27x squared over a 2 minus x to the power 4 over 4 there. You have a 3 and you have a 0. We are done integrating. Okay, so now we're going to say in the first bracket, we're going to say 27, where there is x, we plug in the upper limit, so it's going to be 3 squared everything over a 2 minus there where there is x, we're going to put a 3 to the power 4 over a 4. That's in the first bracket, minus in the second bracket, wherever there is x, we're putting the lower limit, which is a 0. So it's going to be 27 0 squared over 2 minus 0 to the power 4 over a 4. Okay, you compute. So here, because we have a 0 on the right bracket, in the right bracket, it simply means that 0 will cancel everything. Oh, that's too much. Go back up. Okay, I think we can even remove the ruler. Okay, let's just spin it out of the way. Yeah, like that. Oops. Okay, let me just remove it. Draw. All right, so you notice here there is a 0. It will cancel everything here. 27 times 0 is 0. 0 divided by 2 is 0. 0 to the power 4 is 0. 0 divided by 2 is 0. 0 minus 0, 0. So this bracket is pretty much cancelled, this one. We just focus on the answer we get from this bracket. So meaning we just punch those values there, which is you just punch those values. Let me confirm whether I've punched the correct values. Okay, so the final answer it's giving me is, remember we're finding area, so we're getting 109.35. This is area, so it's going to be units squared. In case you found a negative answer, you need to convert it to a positive, because area is always supposed to be positive, and you are done. Okay, so that is pretty much how we solve this question. So tomorrow at 20 hours we're going to have a live session. Please make time, and we're going to look at the second part of this topic, which is where you are given a table of values. They hide one of the values and then they ask you to draw the graph. Of course, that's after you've found the hidden value. You draw the graph. After drawing the graph, then they will ask you those follow-up questions similar to what we have looked at in this session. So those who missed the class, make sure you go through this lesson so that you better understand what we're going to look at in the next session, because certain things that I've already spoken about here, I won't speak about them in depth because I know we've already introduced them. So otherwise, that is all I had for you in this session. Thank you for your time, and I'll see you. At this point, you can now attempt those questions I gave you, the exam questions I gave you in the group. Yeah, so enjoy the rest of your evening and good night.